All right, mathletes, here we are looking at problem solving with Venn diagrams. When we're problem solving with Venn diagrams, we're going to use the information that we know in order to find unknown values in regions of Venn diagrams. So with a Venn diagram, we got to recognize that we have 4 unknown regions in this diagram. Or right now they're unknown. So I'm going to label them as A, B, C, and D. Remember, those are, when I put the brackets around, it's how many elements are in that region. Okay, so looking at this original problem, I'm going to see that a tennis club has 42 members, 13 have fair hair, 15 have blue eyes, and 22 have neither fair hair nor blue eyes. So the first bit of information I'm going to use is this. Okay, so that tells me the number of elements. My universal set is 42. Okay, so because I also know that 22 have neither fair hair nor blue eyes, that's not in F and not in B. So I can see that that implies that my D must be equal to 20. Okay, I'm sorry, my D is equal to 22. Okay, because that represents the number of people that neither have fair or blue eyes. Okay, so making another step here, I know that all 4 regions, A plus B plus C plus D, needs to add up to 42. Well, if D is equal to 22, I do A plus B plus C plus 22 is equal to 42. I can see that these 3, A plus B plus C, must be equal to 20. Okay? So using that information, I want to now start using this next bit of information. Okay? So I know that A plus B, okay, the number of people that have fair hair, okay, that A plus B needs to be equal to 13. Okay, combining the equation from above, okay, and substituting in A plus B is equal to 13. So using this same equation, I'm going to say A plus B, well, I know that's equal to 13. Now plus C is equal to 20. So now I can determine that C must be equal to 7. Okay. So now I'm going to jump in and use this information. So now that I know that C is equal to 7, I'm kind of getting ahead of myself. I want to go ahead and put 7 there next to my C. Okay. So now I know that 15 have blue eyes. Well, the elements that have blue eyes are in this region. Okay. So that means that B plus C must be equal to 15. And again, using this equation here, okay, I'm going to do a substitution. So if B plus C is equal to 15, that A plus, well, B plus C is 15, and that's equal to 20. So by solving this, subtracting 15 from both sides, I see that A must be equal to 5. So now I'm here. So I know all of them in my region except B. So how am I going to solve for B? Well, I know A and C. So again, I'm going to use this equation again and plug in the 2 values I know from before. So I have A plus B plus C is equal to 20. Well, I know A is 5. I know C is 7. And I'm trying to find B. So have that is equal to 20. From that information, I see that B plus 12 is equal to 20. So therefore, B must be equal to 8. Okay? So now I know all those regions. So I've shown that information on the Venn diagram. Now I want to answer questions in B. So find the number of members with fair hair or blue eyes. When we see or, okay, this is F union B. Okay, so they could have fair hair, blue eyes, or they could have both. Well, the number of elements in F union B is equal to A plus B plus C, which is equal to 20. Okay, and I know that from right there. All right, the next one asks for the people with fair hair but not blue eyes. So fair hair but not blue eyes, so intersection of not blue, so that's the complement of B. Okay, so that is going to be right here in this region. That there's 5 people that have fair skin but not blue eyes. Let's look at a second example here. Okay, so notice here we're dealing with 3 sets. So a football team has training on Tuesday, Wednesdays, and Fridays. Of the 40 players in the squad, 21 attended training on Tuesday, 25 attended training on Wednesday, 24 attended training on Friday. 11 players attended on Tuesday and Wednesday, 15 attended on Wednesday and Friday, and 14 attended on Tuesday and Friday. 6 players attended all 3 training sessions. So again, I'm going to set this up and label out my regions. So let's call this region A, region B, region C, region D, region E, region F, and region G. And then we can't forget the ones on the outside. Okay, so first thing I need to know is that I know already region E, so I'm going to go ahead and just erase that, because I know the number of players that attended all 3 training sessions. So that's equal to 6. So that's going to help out. So next, I'm going to jump in to, I know the number of players, okay, that attended training on the 2 days a week. So right here, I'm going to use this information, okay? The number of players that attended Tuesday and Wednesday, okay? Well, that's equal to 11. Well, I know that T intersect W is including this region and this region. So that means that 11 must be equal to B plus 6. So therefore, B must be equal to 5. Okay. Using that same train of thought, I'm going to jump into this next one. Okay. I have the number of players that attended Wednesday and Friday. So and is always the intersection. It has to meet both criteria. Okay, Wednesday and Friday is equal to 15. Well, Wednesday and Friday are here and here. So that means it's got to be equal to F plus 6. Well, subtracting 6 to both sides, I see that F must be equal to 9. Okay. Use the other bit of information, okay, right here. So the number of players that attended Tuesday and Friday is equal to 14. Well, Tuesday and Friday is D in the middle. Okay, so I'm going to go ahead and say that D plus 6. Okay, well, solving this equation, subtracting 6 from both sides, I see that D is equal to 8. I'm going to go ahead and erase these and fill these in. So now that I know these, okay, they can help help me unravel a bigger picture and find some other ones. So F was 9 and D was 8. Okay, so now I'm going to just kind of shorten this up so I have plenty of room to go on to the next one. kind of put this off to the side over here. Okay. Now I want to use some other information. And just for the sake of argument, I'm going to erase this up here so we can see, all right, we've used that information. Next, what I want to use is this information. Okay. I have 41 attended trainings on Tuesday. So Tuesday, now that I look at Tuesday, I see that that's A plus 5 plus 6 plus 8. Because they might have attended on Tuesday and Wednesday, they might have attended all 3 days, and they might have attended on Friday, and they might have just attended on Tuesday. So I need to add up all those different regions, and I know that 21 of them attended those days. Okay, so 5 plus 6 plus 8 is 19, so I get A plus 19 is equal to 21, so therefore A is equal to 2. So I'm going to go ahead and erase the 2 that there, and I know that it's 2 there. Okay. Now I want to go ahead and solve for using this information. So Wednesday. So Wednesday, I see that I need to include this information here. So what were the players that attended on Wednesday? Well, I have the 5 players that attended Tuesday, Wednesday, the 6 that attended all of them, plus the 9 that attended Wednesday and Friday. I don't know how many players attended just on Wednesday. That's my C. So all those together need to add to 25. Okay. 5 plus 9 plus 6 is going to be 20. Plus C is equal to 25. So therefore C is equal to 5. Okay. Have that information, so I'm going to go ahead and put it there. Okay. And for the last one here, I'm going to use this information. Following the same set of logic, I'm going to see that that's for players attending on Friday. Okay. So on Friday, I see that it's got to be the 8 plus the 6 plus the 9 plus the G is equal to 24 players. Okay. The 8 plus 6 plus 9 is going to be 23. Plus G is equal to 24. So G is equal to 1. I'm going to head and erase that and put 1 here. Okay. And the last piece of information is I need to still find H. Okay. So to find H, I need to be able to add these all together. And of the 40 players in the squad, so I know there's 40 players in the squad. Okay. So if I add these all up, I get, now over here I'm going to do 2 plus 5 plus 5 plus 8 plus 6 plus 9 plus 1. So I'm going to get 10, 12, 20, 35, that's 36, plus now my H needs to be equal to 40, so I get H is equal to 4. Okay, so now I can put in 4 here. I need to remember that since these are not actually what's in the sets here in the Venn diagram, but the number of them there, I want to put brackets around each one of these to tell me that's how many are in that region. Now that I've finished my Venn diagram, I can answer my questions. So, how many players attended training on Wednesday only? Well, that's talking about this category right here. Wednesday only, so we had 5. The number of players that attended on Friday, but not Tuesday, so Friday, but not Tuesday, is going to be these 2 groupings there. So that is going to be 9 plus 1. That is 10 players. The final question we have here is exactly 2 of the days. Well, exactly 2 of the days means they didn't go to all 3 of them, and it includes, well, they could have gone to Tuesday and Wednesday, they could have gone to Tuesday and Friday, or they could have gone to Wednesday and Friday. So those added up together is 22. That concludes our notes for today on problem solving with Venn diagrams.